We're going to look at a few problems in section 12.1 and see if we can help you to understand a few of these problems. In order to introduce this, I want to look at an example that maybe you can relate to in church work. So at one of the churches that we served at, there was a deacon rotation. It's a small church, and the chairman of the deacons actually rotated through the list of deacons. And so let's just say you're going to set up a deacon rotation with rotating chairman for every year. And so you've got these, your small church, these are your 5 deacons, and you're going to go ahead and get that set up. So probably the easiest thing to do would be to say, okay, we're going to set this up. Mr. Smith will be the chairman for the first year, Mr. Jones the second year, and so on, all the way to Mr. Sanders. Well, if it's like some places we've been at, let's just say Mr. Smith decides, you know what, I just don't feel comfortable being the chairman for the first year. So then you're just like, okay, well, let's do it a little differently then. So, and let me get my screen to go back the way it's supposed to. There we go. So let's say that you're like, okay, well, we'll let Mr. Jones be the chairman for the first year, and then we'll let Mr. Smith do it for the second year. So, well, that would be fine, except that now Mr. Sanders is saying, you know what, I just don't know that I want to wait 5 years before I'm the chairman. I think I'd rather do it sooner and just go ahead and get that over with. And so you swap again, and you're like, okay, well, Mr. Jones seems to be okay with year 1. We'll just swap Smith and Sanders. Well, you can see that this could go on. And really, I just wonder how many different versions of this deacon rotation can there be? So let's take a look about that in math terms. So the first year you have 5 choices. You have these 5 men. Now, after that, you go ahead and you pick the first person. And so you're going to say, okay, Mr. Williams, you're going to be chairman for the first year. And then the second year, now you have 4 choices, and you're going to pick somebody for that one. Let's say Mr. Baker gets the second year. And then the third year, you're left with 3 choices. And so you kind of see the pattern that this follows. So basically in year 1, you have 5 deacons to choose from. Year 2, you have 4, 3, 2, and then there's just 1 deacon left by year 5. That would be the chairman that year. So it turns out mathematically that you can take and multiply 5 times 4 times 3 times 2 and times 1. And when you do that, you get 120. So there are 120 different ways that you could arrange these 5 deacons in this deacon rotation. Now, aren't you glad that we're not going to go over each one of them, because we'd be here forever. So it turns out there's also a term that we use in math, and it's called the factorial. So when you start and you have 5 factorial, what 5 factorial means is 5 times 4 times 3 times 2 times 1. So we call that 5 factorial. So rather than having to write this out, that's what this 5 with the exclamation point means. And even better news is that you can do factorials on your calculator. So this is a calculator from my computer that I just brought up a little snip of, and I chose the scientific calculator. If yours is not set to scientific, you can actually click on those 3 lines and you can choose scientific. There are a lot of different, you can actually Google free scientific calculator and you can pull one up as well. So this little button that I've circled in red, that is your factorial key. So it turns out that if you hit the 5 and then you hit this button right here, this is what you're going to see on your screen. It's going to come up fact 5, which means 5 factorial, and it's going to give you the answer of 120. So it kind of saved you some time. Imagine if you had 50 factorial. I mean, who wants to type in all those numbers, right? So rather you can just type it quickly using this. So that's a nice little trick. You'll probably use it quite a bit in this section. All right, so our next term is called permutations. This is where we are arranging objects in a specific order. So in other words, our arrangement of those deacons, that was a permutation because they would have to be arranged in a specific order. So there's a formula. This is the formula, which as it looks right now, may not mean a whole lot, but what this means is that we are going to take n objects, so n objects, and we are going to take them r at a time. So in other words, we're going to arrange them by however many this r is. So in our deacon example, we had 5 deacons, and we were going to have 1 chairman each time. So this would have been a 5, and this would have been, the R would be a 1. And then you plug it into this formula. So let's actually look at an example. Let's say you had 31 objects, and we want to know how many different ways can I arrange 5 of those objects at a time? How many different arrangements are there going to be? Well, we plug this in. So 31 is N, 5 is R, and we're going to plug it into this formula. So the numerator is 31 factorial, and the denominator is 31 minus 5 factorial. Now let's do a little math to simplify this. So really that's 31 factorial over or divided by 26 factorial. Okay, so because 31 minus 5 is 26. Now it turns out that you can just grab your calculator and you can actually put into your calculator 31 factorial divided, that's what this line means right here. So whenever you have a fraction, that means divided by 26 factorial. And then when you just hit the enter key, this is the answer. So it turns out if you had this as a problem, this would be your answer. Now, very important, whenever you put this answer into WebAssign, do not put the commas. WebAssign does not like commas, so leave commas out. So just make sure you know to do that. So your answer would be this 20,389,320. Okay, so I'm glad I don't have to figure all of those out. All right, now there are some other problems in your homework where they give you one number and then they leave the second number as a variable. So it turns out that you just have to plug that in. And so when you plug that into the formula here, when we plug that into the formula, we have, and this is actually your answer. This is your answer that would go into WebAssign, 31 factorial over 31 minus R factorial. Now, the problem with this particular problem is not that you can't get to the answer, it's how do you put the answer into WebAssign. So you actually, when you work on this problem in WebAssign and you go to put the answer in, this little part, this little menu comes up and it's way over here on the right side of your screen. So you'll have this particular math pad, which helps you to type in math language. So you're going to click this button right here, which is your fraction button. And when you do, you're going to see something like this. It's going to come up inside of your answer. So then what you're going to do is you're going to click inside this top box and you're going to type in 31 exclamation point. Then you're going to type into the denominator box, and you're going to type this just like you see it, parentheses, 31 minus R, parentheses, and your exclamation point. And this is your answer. All right, so your problem, you're probably going to have different numbers than this right here, but this is how you put this into WebAssign. I know that WebAssign is very particular, but that's all we have to work with right now. All right, now we're going to have a few other problems. One is similar to this. How many permutations are there in the following word? Banana. Basically, that is asking how many different ways can we rearrange the letters in banana? So the problem with this particular question is, and this word is that you are not able to distinguish this A from this A from this A. They're all just an A. So those are not specific. Like there's no way for us to say, okay, that's the red A, the blue A, the yellow A. So I can also say these two look, all three of these words look exactly the same. It's just they swap those A's around. So that's the difficulty in this particular problem. So in this problem, we have 6 letters total. So 1, 2, 3, 4, 5, and 6. Now, how many distinct letters? So how many different letters do we have? And that means, so we have 1B, that's 1B. We have 3 A's, 1, 2, 3. And we also have 2 N's, 1, 2. So really, we're just arranging these 3 letters. So it makes our formula go a little bit differently. So in this case, what we're going to do is we're going to have the 6 letters that we have up here. That's going to be in our numerator. And then we're going to divide by the distinct letters. So this 1 factorial came from this 1B. There's 3 A's, and that's what came from that. And then there's 2 N's. So this is going to be how you would solve this problem. So it turns out that if you do 6 factorial on your calculator, you get 720. 1 factorial is 1, 3 factorial is 6, and 2 factorial is 2. So you actually get 720 divided by 12, and that answer is 60. So there are 60 ways for you to arrange the letters in the word banana. And these are all, these would be 60 different ways. Okay. At any time, just know that you can pause the video and rewind it if you need to. Okay, now we're going to look at another problem. In how many ways can a president, vice president, and secretary be elected from a group of 5 people? Now, what I want to do is I want to underline these important things. So we're looking for a president, a vice president, and a secretary, and it's coming from a group of 5 people. So we are arranging these things. So we have 5 people, and we have 3 different offices: president, vice president, and secretary. So we're going to pull back our formula, and we're going to have 5 to choose from, and we're filling 3 offices. So we're going to go back to that formula that says then we would do 5 factorial divided by 5 minus 3 factorial. 5 factorial is 120. This would be 2 factorial. Now 2 factorial is just 2 times 1. So that's where we got this 2. And 120 divided by 2 is 60. So the answer here is also 60. Okay. Now, another problem. The pick 3 at horse racetracks requires that a person select the winning horse for 3 consecutive races. Now, 3 consecutive races means like one race behind each other. Like there's going to be 3 races, one behind the other. If the first race has 15 entries, the second race has 11 entries, and the third race has 9 entries, how many different possible tickets might be purchased? So they want to know, like, if you were going to go to this horse race track and you were going to buy these tickets, how many different ticket combinations could there be? So we have 3 consecutive races, 15 entries for the first, 11 for the second, and 9 for the third. So let's kind of break it down a little bit more. The first race, you have 15 entries and you're basically going to choose who you think is the winner. So this would be that you actually just have 15 choices to choose from. You have 15 horses, so there's 15 possible tickets that you can purchase out of that one. All right. The second one is going to be that you have 11 entries and you're going to choose one of those. So that would be 11. Okay. Then the third one is going to be that you have 9 choices and you're going to pick one of those. So there are actually 9 horses there. So that's your first, second, and third. Now in math, what we're going to do is that we are going to say 15 times 11 times 9, because that's how many choices you have. So there are actually 1,485 different ticket combinations that you could make for this particular pick 3 contest. Okay, so hopefully that's okay. We just multiply these numbers, 15 times 11 times 9. All right, now I think this is our last example we're going to look at. Suppose you flip a coin and keep a record of the results. In how many ways could you obtain at least one head if you flip the coin 5 times? So notice that each time you flip a coin, you're either going to get heads or tails. So the key word here is that you want to obtain at least one head. Okay, we're going to flip it 5 times, but we have to have at least one of those 5 times. It has to be a head. All right, now each flip you're going to get heads or tails. So here's on my 5 flips. All right, so on the first flip you have 2 choices. You could either get a head or tail, right? Same thing for the second and the third and the fourth and the fifth. All right, so for each one of those flips, you have two different possibilities. So in math, we multiply all of those together. And when you multiply 2 times 2 times 2 times 2 times 2, you get 32. So there are 32 total. But we have to go back and we have to look at this thing that says at least one head. So now I want you to think about, is there any particular case in which you wouldn't get at least one head? Okay, so is there any combination of all of these flips that you wouldn't get at least one head? So think about that for a second. So it turns out that if you were to flip tails, 5 times, then you would not get at least one head. So now this particular option, that particular combination is actually one of those 32. So this one, we have to eliminate this from all of these possibilities because they want to know how many ways could you obtain at least one head. So you could have 2 heads, 3 heads, 4 heads, 5 heads. You could have all 5 of them be heads, but we have to eliminate this one particular one where we get all tails. So in that case, we have to say 32 minus that one case. So your answer here would be 31. Okay, I know that was fast, and I hope that this will help you through a few of the problems in the section. You may need to go back and replay this particular video a couple of times. Please let me know if you have any questions or need any additional help, and I will be more than happy to help. Thanks so much.